So these are your notes for our next lesson. As you know, we finished up circles right before spring break. And instead of staying in chapter 9 and working on surface area and volume, which those can be some pretty challenging lessons, we decided to jump ahead up to chapter 12 and start with something a little easier. And then hopefully we'll be back at school sometime in April, and then we can get to those more challenging lessons face to face. So hopefully that'll happen. I honestly don't know, but here we are. So anyway, this is your first lesson for virtual school. It's in your Go Math book in chapter 12. I know most of you don't have your books with you at home, but remember you can always access the textbook using going to ClassLink and then clicking on that HRW app. And you will have some assignments to complete through that app later on this week, so you might want to start getting a little familiar with it and looking at the different resources available to you through your online textbook. So if you have your blue folders, go ahead and take out your blue folders, and a lot of these definitions should be there for you in your blue folders. If not, just use a regular spiral notebook or just paper and pencil, but you want to copy down these notes and the practice problems so that you know how to do the assignments that you will see later on this week. And if I go a little fast, since I'm not standing in front of you, I don't know how long it takes you guys to copy down. You can always just pause me and take a few minutes to catch up and then resume wherever you are. All right, so today we're talking about probability. We just have a few new definitions before we get into our practice problems. So make sure you copy down these definitions so that you're familiar with these words that I'll be using within the lesson. All right, our first definition is experiment. Oh, let me click on full screen. That way we won't get pop-ups. All right, an experiment is an activity involving chance in which results are observed. So any type of activity that you do where there could be different outcomes that happen. So while we write down these definitions, I'm going to use the example of rolling a die. Most of you have played board games before, so you're familiar with a dice. When you roll them, there's 6 sides, so you can get a different outcome of 1, 2, 3, 4, 5, or 6. So the trial is each observation of an experiment. Each time you roll that die, that's a different trial. And then the outcome, as you heard me already say, that's the result that you get from landing on the die. So I could roll the die and land on a 1, that would be the outcome. I could roll the die and land on a 4, that would just be a different outcome. It's a different result. All right, and then the sample space is the set of all possible outcomes for an experiment. So if we're rolling a die, we know that there's 6 different possible outcomes because there's 6 sides on our die. We could get a 1, a 2, a 3, a 4, a 5, or a 6. All right, so now going into finding probability. So probability is the likelihood that the certain event will occur. In order to find probability, you will need to know what your sample space is. So you would need to know how many different outcomes there are for that experiment. So we write probability. Probability can be written 3 different ways: a fraction, a decimal, or a percent. So the easiest way to find it to start off with is by getting the fraction. And then from there, you can change your fraction to a decimal and then your decimal to a percent. All right, so we write probability with a P. So P obviously stands for probability. And then the event, the outcome that you want would go in the parentheses. And this is called theoretical probability, when you're just finding what is the likelihood that it will happen based on the total different number of possible outcomes. So I did a little example here. Excuse my messy handwriting. I had to use the mouse to write since I don't have my smartboard in front of me. So I started with finding the probability of rolling a 2 on a die. So if you look at my sample space up here, I only have one outcome that is a 2. So the number of favorable outcomes, which goes at the top of your fraction, it's the numerator. Since there's only 1, 2, we put the number 1 on the top of our fraction. The denominator is the total number of possibilities. So I know when I roll my die, I can get a 1, a 2, a 3, a 4, a 5, or a 6. So that's 6 different numbers. So my denominator is a 6. So 1/6 would be the theoretical probability written as a fraction. From there, we can change our fraction to a decimal. Remember, to change a fraction to a decimal, divide the numerator by a denominator. And yes, you are allowed to use your calculators for this. So when I picked up my calculator, I did 1 divided by 6, and I got 0.1666666. So we can see that the 6 is repeating, which is why I drew the line over it. And then to change our decimal to a percent, we just move that decimal point 2 to the right. And then I just rounded to the nearest whole percent, which is how I came up with 17%. So that's your probability as a fraction, a decimal, and a percent. All right, we won't have to do too much of that today. What we're going to be looking at today, let's see if I can move that up a little bit so that you don't have that in your way, is just what is the likelihood of an event occurring. So we don't have to find the exact probability, we just have to see if it's impossible, unlikely, as likely or not, likely or certain to happen. So you would need to think about what the fraction would look like and figure out if that number would be a 0, which would equal impossible. If it's a number greater than 0 but less than a half, then it's unlikely to happen because there's just a low chance of that happening. If it's exactly a half, we call that as likely as not. That just means that there's an equal chance of it happening or not happening. Moving on, if the fraction is greater than a half but less than 1, we would call that likely. So it's likely to happen because it's more than a half. And if it's definitely going to happen, that means your probability will be equal to 1. So remember, for a fraction to equal 1, you have the same number on the numerator or denominator. Then we call that certain. It's definitely going to happen. Okay, so make sure if you don't have your blue folders, make sure you write down this little table right here. This will be your cheat sheet for doing your assignments today and for later on this week. So I'll give you a couple seconds to copy down that table. That's very important to have. And then we're going to move on. I just have 10 examples that we'll do together, and you can see exactly what you will be doing. Okay, so pause the video if you need more time. If not, I'm going to go ahead and move on. Oh, here's my little toolbar down here. Okay, so we're going to be looking at some different events, and we just want to write if the event is going to be impossible, unlikely as not, likely, or certain. So let's go ahead and look through these, and I'll kind of talk about them as we go. Although I think I might need to get my toolbar back up. So bear with me, guys. This is kind of I'm kind of learning along with you. All right, here we go. So I'll be able to just type right in here. Okay, so number 1, this says selecting an even numbered card from a deck of cards numbered 1 through 30. Okay, so if we need an even number card and we have 30 cards, we know half of them would be even and half of them would be odd, right? So we don't actually need to count them all out. We know that half of the cards are even numbered. So if the probability is equal to a half, we're just going to write out the words as likely as not. That's all you have to do because we know there's an equal chance of getting even and an equal chance of getting odd. Okay? All right, let's see what number 2 says. Number 2 says spinning red on a spinner with sections evenly divided into green, blue, red, and white. So I see we have 4 different sections and only one of them is red. So that would be a probability of 1 out of 4, correct? So now think, is 1/4 more than a half or less than a half? Well, less than a half, because if there's 4 sections, we would need 2 of them to be red in order for it to be equal to a half. So since 1/4 is less than a half, so 1/4 is just what we're thinking. We know that it's less than a half, so our answer is going to be unlikely. So I'm just going to write unlikely. So there's a not very likely chance that we would land on red because it's only 1 out of the 4 sections. All right, number 3 says rolling a number greater than 2 on a standard number cube. So standard number cube is just our typical die or dice die is singular. And we know on a regular die, there's 6 sides. So just like the example I used in the beginning part with the definitions, if we have 6 sides, numbers greater than 2 would be 3, 4, 5, and 6. So that's 4 numbers. So we have 4 out of 6 numbers that are greater than 2. So my fraction 4/6, which we know simplifies to 2/3, is that more than a half or less than a half? Well, it's more than a half. In fact, without even simplifying it, we know half of 6 is 3. So since 4 is more than 3, that's more than a half. So that would be likely to happen. So I'm just going to write likely as my answer. So these questions aren't asking for the actual probability. So I'm just kind of thinking about what it is and then writing one of the 5 choices from the top. So that is likely to happen. All right, number 4. So we're still talking about a number cube. This one says rolling a 7 on a standard number cube. All right, so we've talked about this. A number cube only has 6 sides. What are the chances that we're going to get a 7? I don't see any 7s on a number cube. So that would be a 0 out of 6 chance of getting a 7. So which of these would make the most sense to write for rolling a 7 on a number cube? I think that's pretty impossible. So my answer for this one would be impossible. So when they give you a choice of something like that just can't happen, that's what impossible is. There's a 0 probability of that event occurring. All right, number 5. So now we're talking about flipping a coin. We know when we flip a coin, we can get heads or tails. So there's 2 different outcomes. One of those sides is heads. So 1 out of 2, so 1/2. So we know that if the probability is a half, that's the same as likely or as likely as not. As likely as not. So that's what we would write for that one. All right. Hopefully you guys are starting to get the hang of this. If not, remember we will have a live video chat where I'll be available. We can maybe do some practice problems together. All right, number 6. Drawing a red marble from a bag filled with only red marbles. So we only have red marbles in the bag. So we're definitely going to pull out a red marble. So we don't even need to know how many marbles there are in this case because we know they're all red. So the probability of pulling a red marble from a bag of only red marbles would be 1 whole. It's certain to happen. There's no other outcome that we could get besides getting red. All right, we're almost done. Let's see. Number 7 says rolling a number greater than 4 on a standard number cube. So how many numbers are greater than 4? We have 5 and we have 6. So 2 of the numbers on a number cube are greater than 4 out of 6 total numbers. So that would be a probability of 2 out of 6. And 2 out of 6 we know is less than a half. So that one we're just going to write unlikely because 2 is less than 3. So 3/6 would be equal to a half. 2 is less than 3, so it's unlikely. All right, number 8, rolling a number less than or equal to 2 on a standard number cube. So less than or equal to 2. That would be a 1 or a 2. So this actually has the same probability that we just had in number 7. So our only outcomes would be a 1 or a 2. So again, that would be 2 out of 6, and 2 out of 6 is less than 1/2. So again, that would be unlikely.